So this is going to be a review video for the mole. Now, as a reminder, a mole is just another way of counting things. Just like 1 dozen equals 12 items, 1 mole equals 6.02 times 10 to the 23rd items. And this number is called Avogadro's number. And what this number does is this allows scientists to count a lot of very small things. Now, we can write this Avogadro's number in two ways. We can say that 1 mole is 6.02 times 10 to the 23rd particles. Or we can say 6.02 times 10 to the 23rd particles is 1 mole. Now, keeping in mind, particles can be anything from compounds to atoms to formula units if it's ionic. So here's our first sample problem. 2.5 times 10 to the 23rd atoms of iron equals how many moles? So we always start off by writing what we know. 2.5 times 10 to the 23rd atoms. Now we're going to use that ratio of moles to particles, and in this case we're going to use atoms, that we had on the previous slide in order to get to atoms. So if I want to cancel out my atoms, I'm going to put my 6.02 times 10 to the 23rd, or Avogadro's number, on the bottom, and my 1 mole on top. And when I do this in a calculator, I get 0.42 moles of Fe, moles of iron. Now, the reason why I chose my 1 mole over 6.02 times 10 to the 23rd atoms is because my atoms will now cancel with atoms, and I'm left with my mole on top. Okay, sample problem number 2 here, we're going to go the other way. We're going to start with our moles of manganese and calculate how many atoms that would be. So just like before, write down what we know. 2.5 moles of Mn. Now we're going to use our other ratio this time. Since we want moles to cancel, we're going to put our mole on the bottom, and we're going to put our Avogadro's number on top, because it's 6.02 times 10 to the 23rd atoms in 1 mole. In a calculator, we will get 1.5 times 10 to the 24th atoms. Now, the reason why I chose this one is because we want our moles to cancel, so moles on top, moles on bottom cancels, and we are left with atoms on top, which is what we are looking for. Molar mass is the mass of exactly 1 mole of a substance. It could be 1 mole of carbon, it can be 1 mole of oxygen, or it can be here 1 mole of a compound, such as SO3. So in order to calculate this, what we want to do is we want to add up the individual molar masses, and this is found on the periodic table. So sulfur, S, he weighs 32.07 grams per mole. Oxygen weighs 16.00 grams per mole. Now, in order to add these up, what we're going to do is we're going to go 32.07 grams per mole plus 3 times 16.00 grams per mole, because we have 3 oxygen atoms, and we get 80.07 grams per mole. So that is the molar mass of SO3. So if we have exactly 1 mole of SO3, it will have a mass of 80.07 grams. And if we have 80.07 grams of SO3, that means we have 1 mole. The mole-mass relationship lets us convert between moles to mass and vice versa, from mass to moles. And we can use our fraction in two ways. We can have the molar mass on top for 1 mole, or our 1 mole on top of molar mass. Now I'm going to use this left side, molar mass over 1 mole, if I'm going from moles to mass. And I'm going to use this right side if I'm going from mass to mole. Reason why is that if I want to go from mass to mole, so if I want to go from my mass to mole, I want my mass on the bottom to cancel. And then here, if I'm going from mole to mass, I want my moles to cancel. So here's my first example. I have 9.45 moles of Al2O3. So my first thing is I'm going to be going from moles to grams. So I want to use my ratio of grams, my molar mass on top, divided by moles. So 1 mole on bottom, and my molar mass of Al2O3 you would need to calculate, which I have already done so and found out to be 101.96 grams. So now when I go to do my math, my moles will cancel and I'm left with grams, which ends up being 964 grams of Al2O3. Now say I want to look at this the other way. What if I had another mass? So let's say if I had 500 grams of Al2O3, and I want to figure out how many moles I want to get to. Well, I'm going to just flip my equation. So 1 mole over 101.96 grams. So now my grams will cancel with grams, and I am left with moles. And my answer is 4.90 moles of Al2O3. So to summarize, for the mole to mass relationships, what you want to do is keep in mind what you are trying to go to. So in my fraction, if I want to get to my mass, I'm going to have my molar mass on top over my mole, 1 mole, because I want my moles to cancel. If I'm trying to get to moles, I want to have my 1 mole on top and my molar mass on the bottom, so that my mass will cancel with what is given. So you always want to have what you want is going to be on top. So my molar mass is going to be on top if I want to get to mass. My moles is going to be on top if I want to get to moles.